Welcome to the Explainer. Every single day, massive leaps in both science and business are actually running on a quiet, powerful engine, and that engine is hypothesis testing. Think back to the infamous launch of New Coke in the 1980s. It was a monumental business blunder, right? And it was completely driven by this fatally flawed assumption that a sweeter taste in a blind sip test would automatically equal long-term market dominance. So how do we prevent those kinds of catastrophic missteps? How do we actually take our assumptions, structure them, and validate them with real data instead of just guessing? Well, today, we're unpacking the statistical frameworks that allow us to do exactly that.
Okay, let's dive into this. The big question, how do we formalize our decision-making? Now, don't get me wrong, intuition is incredibly valuable. It's almost always what sparks an initial hypothesis. But here's the catch. Intuition alone just doesn't scale. When you're standing at a strategic crossroads, your intuition needs a robust bridge to transform that messy human instinct into a formal, structured process. We absolutely need a rigorous method to confidently move beyond gut feelings and anchor our choices in reality. And hypothesis testing is precisely that framework. It formalizes our decision-making. This isn't simply about abstract math or crunching numbers in a spreadsheet. It's the ultimate structured antidote to informal choices. It's a filter for objective evidence. It gives us a systematic way to eliminate cognitive bias, isolate the absolute truth within our data, and make calculated choices. It acts as the definitive bridge between an initial hunch and a statistically proven fact. In practice, this framework operates on a strict, four-step life cycle. Step 1. Establishing the null and alternative hypotheses. Step 2. Calculating the test statistics. Step 3. Setting significance levels. And finally, Step 4. Applying decision rules. It's a precise sequence, and this engine runs dependably every single time you need to rigorously evaluate an assumption.
Let's look at the philosophical tension right at the start of this process, pitting the null hypothesis directly against the alternative hypothesis. Why is this binary showdown so absolutely critical? Because establishing a strict baseline, the assumption that nothing has changed or there's zero effect, forces your new theory to clear a mathematically rigorous hurdle. The integrity of the entire test relies on framing this initial contrast perfectly.
And this brilliantly illustrates what happens next. Once those hypotheses are locked in, you need the right analytical tool. Think of this as the decision-maker's toolbox. Choosing the wrong statistical measure here can be disastrous. Just look at Simpson's paradox, where a clear trend that appears in different groups of data completely reverses when you combine those groups. It's wild. Hypothesis testing gives us highly specific instruments to evaluate our test statistics, ensuring you have the exact mathematical fit for the complex question you're asking.
Statistics offers specialized tools for specialized questions. Think of it like a matching game. We rely on a specific set of core tests: the t-test, the z-test, the f-test, and the chi-square test. Each one is mapped directly to a distinct analytical function, from means and correlations to variance ratios and goodness of fit. Let's break down these pairings so you know exactly which instrument to leverage for your specific data.
Let's move to and see how this builds. Our first tool is the t-test, which is explicitly designed for analyzing means. What's super fascinating about the t-test is its origin story. It was actually invented way back in 1908 by William Seeley Gossett, who was a chemist working for the Guinness Brewery. He needed a mathematical way to monitor the quality of stout using incredibly small sample sizes. Well, over a century later, whether you're comparing average marketing channel performance or manufacturing output, it remains the absolute gold standard for evaluating means.
Next up is the z-test, which handles correlations. If your focus shifts from simple averages to how distinct data points move together, this is your tool. Think about high-frequency trading in financial markets. Quantitative analysts use z-tests to uncover non-obvious correlations between entirely different asset classes. It allows them to formalize relationships that would be completely invisible to the naked eye. Now, pivoting from how data points relate to how they spread, we arrive at the f-test. This one evaluates variance ratios, because sometimes the most critical insight isn't the average at all, it's the volatility. In global supply chain management, for example, knowing the average delivery time is helpful, sure, but understanding the variance, how wildly those delivery times actually fluctuate, is what really prevents catastrophic inventory shortages. The f-test lets you rigorously compare that exact volatility. Finally, we have the chi-square test, a massively powerful tool for measuring goodness of fit or independence. Say you need to determine whether your observed data fits an expected distribution, or if two categorical variables are truly independent. For instance, testing if the efficacy of a groundbreaking new drug in a massive clinical trial is completely independent of regional demographic variables. When you need answers like that, this is the instrument you deploy.
So, the crucial point is this. Each test provides a structured way to accept or reject assumptions.
The underlying math is truly just a vehicle. The actual destination is objective confidence in your actions. This framework gives you, as a decision maker, a rigorous, mathematically sound method to definitively validate or entirely dismiss the things you initially assumed were true.
So which assumptions will you accept or reject today? Now that you have this formal statistical framework available, a highly specialized toolbox ready to move you past mere intuition, the real challenge is application. I highly encourage you to look closely at your current projects, isolate your biggest, most foundational assumptions, and apply this rigor to find out what is actually true. Thank you so much for joining me on this explainer. Keep analyzing and keep learning.